Okay, so hey guys, so today we are going to go over day, I believe 6 notes, single replacement continued. So basically we're going to go over the last 2 rules of single replacement. Okay, so rule number 3 states that any metal that is sodium or above sodium will react with water. Okay, so basically we're going to be looking at our activity series for this one again. Okay, so anything that is sodium or above it is going to be reacting with water. Okay, so your general form for this is going to be, if you have a metal and water, they are going to react. So metal, it's positive, it's going to react with the positive element in our compound, which is hydrogen. Okay, hydrogen is actually, your metal is going to react with only one of these hydrogens, not both of these hydrogens. So it's going to replace only one of those hydrogens. So your compound ends up being OH plus your hydrogen. But remember, hydrogen is a diatomic, so it cannot be by itself. So it'll be represented as H2. Okay, so sometimes it's easier to actually think of water as HOH, because again, what metal is going to be switching with is only one of the H's. So that way your OH can be the one that's combined with your metal. Okay, so let's take a look. Okay, so again, our rule is that our metal will only react with water if it's one of these 5 elements right here. So it has to be sodium or above. So sodium, calcium, barium, potassium, and lithium. Water will only react with these 5 metals. So let's take a look at our examples. So number 1, sodium plus water. So will sodium react with water? Well, let's take a look at our activity series. So is sodium one of these 5 metals? It is. So it will react. A reaction will occur. Okay, so number 2, calcium metal is placed in water. So will calcium react with water? And again, we take a look at our activity series. Calcium is right here. So yes, calcium will react with water. Okay, and then the last one, a sample of cadmium is placed in a test tube of water. So is cadmium one of those 5 metals? And it's not. So no, a reaction will not occur. Okay, so let's go ahead and try to predict these products for the 2 that did create a reaction. So our products, sodium plus water. Remember, sodium is going to replace that hydrogen. It only is going to replace one of those hydrogens. Okay, so sodium and hydrogen are going to switch places. So that's going to leave me with NaOH. Okay, and then remember, hydrogen is now going to be the one that's all by itself, but because hydrogen is a diatomic, it's going to need a subscript of 2. Okay, so now let's go ahead and try to balance our equation. Okay, so this is the important part, because some people get really confused with how to balance hydrogen for these type of reactions. Okay, so sodium, we have 1 here and 1 on our product side. So we know that sodium is already balanced. Okay, hydrogen, we have 2 on our reactant side, but we have 1, 2, 3 hydrogens on our product side. Okay, so hydrogen for sure we need to balance. Okay, if you take a look at the hydrogen in your reactant side, your hydrogen has a subscript of 2. So no matter what coefficient you put in front of your hydrogen, it will always be an even number. Okay, but if you look, okay, at our product side, hydrogen, you have a subscript of 1. So no matter what coefficient you put here, it can be either odd or even. Okay, but remember, it has to be even because water has a hydrogen subscript of 2. Okay, so if I make this even, it'll make it easier for me to balance hydrogen. Okay, so now I have hydrogen, we have 2, hydrogen, we have 2, so 2 plus 2, we have 4 hydrogens on our product side. So if I have 4 hydrogens on my product side, then on my reactant side, I would have to have a coefficient of 2, so that way this can also have 4 hydrogens. Okay, so let's double check. Sodium, we now have 2, so our coefficient on our reactant side is now going to be a 2. So we have 2 sodiums on our reactant side, 2 sodiums on our product side. Hydrogen is already balanced because we said this was 4, and we also have 4 hydrogens. Oxygen, we have 2 oxygens on our reactant side and 2 oxygens on our product side. Okay, so that equation is now balanced. Okay, and then number 2, calcium metal is placed in water. So calcium plus H2O yields, well, what does that yield? Remember, calcium is going to react with hydrogen. Okay, and hydrogen is going to switch places with calcium. Remember, it's only reacting with 1 hydrogen. So your product is going to be CaOH plus hydrogen. And then hydrogen, it cannot be alone, it's a diatomic, so we're going to add a subscript of 2 there. Okay, but I'm going to go back to my compound. Calcium has a charge of positive 2. Hydroxide, OH, has a charge of negative 1. You guys should see that on your polyatomic side of your periodic table. So hydroxide right here has a charge of negative 1. So remember, we crisscross our charges so they can become subscripts. So calcium has an invisible subscript of 1. Hydroxide is going to have a subscript of 2. Okay, so balancing this equation, calcium, we have 1 on our reactant, 1 on our product. Hydrogen, we have 2 in our reactant, but 4 in our product. So I'm going to have to put a 2 coefficient there. Okay, and because I did that, it's going to change the amount of oxygens I have, which I have 2 oxygens here and 2 oxygens on my product side. So that actually balanced oxygen for me. Okay, so everything is balanced. We now have a balanced equation. Okay, so moving on to rule number 4. Halogens will only replace other halogens that are higher in the activity series. So halogens will not replace metals. Okay, use the family on the periodic table. Okay, so remember, like replaces like. That is our rule for single replacement. Okay, so if a halogen will replace another halogen. If you look on your periodic table, let's take a look at why halogens do not replace metals. Okay, so remember that your halogens are in group 7A. So these are our halogens right here. Okay, fluorine is the most reactive, and then astatine would be the least reactive. Okay, so Remember, like replaces like. So fluorine, chlorine, bromine, these are all nonmetals. So if you are a nonmetal, it's going to replace nonmetals in your compound. It cannot replace a metal because they're not alike. Remember, metals replace metals, nonmetals replace nonmetals. So halogens are actually nonmetals. So if halogens are nonmetals, they cannot replace metals. Okay, so again, on your periodic table, these are your halogens. Fluorine is going to be the highest or the most reactive. Astatine is going to be the least reactive. Okay, so let's go back to our notes, and I'm going to blow up this so we can take a look at our halogens in group 7A. Okay, so let's take a look at our examples. Number 1. Okay, so we have fluorine plus aluminum chloride. Okay, so fluorine is going to be a halogen. Okay, it's also negative and it's also a nonmetal. So which one of those is similar to fluorine? Well, aluminum is a metal. It's also positive, so it can't be aluminum. It's going to be chlorine. So chlorine is going to switch places with fluorine. Okay, so we have to check our periodic table. Is fluorine higher than chlorine? Yes, so a reaction is going to occur. Okay, the next one, we have chlorine gas, so that's all by itself, is bubbled through a solution of sodium iodide. So chlorine, that's a halogen. So which one of these is also a halogen? Okay, it's going to be iodide. Iodide is right here on our periodic table. Okay, so is chlorine higher than iodide? Okay, chlorine is in fact higher than iodide. So yes, a reaction is going to take place. Okay, and then the last one, we have liquid bromine is mixed with a solution of potassium chloride. So this is the one that's all by itself. Potassium chloride, well, again, we're still looking at halogens. So bromine is right here. Chlorine is right here. So is bromine higher than chlorine? No, it's not. It's actually lower. So no reaction is going to occur. Okay, so since these two did create a reaction, let's go ahead and predict their products. Okay, so again, fluorine is our halogen, chlorine is also our halogen, so they are the ones that's going to be switching places. So I will end up with chlorine all by itself, and I have aluminum now with fluorine. Okay, remember with your compounds, make sure you have the right subscripts. Aluminum is a +3 charge. Fluorine is a -1 charge. So your subscript should be Al1F3. Okay, and then chlorine is a diatomic, so that's why I put that subscript there. Okay, so to balance our equation, fluorine we have 2. Fluorine we have 3. So what's the next number 2 and 3 have in common? Well, it's not 4, it's not 5, but it is 6, right? So 3 times 2 is going to give us 6 fluorines. So 2 times 3 is going to give us 6 fluorines on our product side. Okay, now let's take a look at aluminum. Aluminum, we only have 1 on our reactant, but aluminum here we have 2. So this is going to have to be a 2. Okay, but because we put that 2 there, let's check out chlorine. Chlorine, we now have 3 times 2, that's 6. So if I only have 2 here, then I'm going to need to make my coefficient a 3. Okay, so now we have a balanced equation. Okay, and then the last one, chlorine gas is bubbled through a solution of sodium iodide. So chlorine gas, well that says That's a diatomic. Chlorine is a diatomic. Okay, so chlorine is bubbled through a solution of sodium iodide. So plus sodium and iodide. Sodium's charge on our periodic table is, let's just, so you guys can see, sodium is right here in group 1, so it's a positive 1 charge. Iodine is in group 7A, and it's a negative 1 charge, so their subscripts are actually just 1. Okay, so we can just leave it as is. So remember, chlorine is a halogen, so it's going to switch places with iodine. Okay, so now what's going to be the atom that's all by itself? Iodine is going to be the one that's all by itself. And iodine is a diatomic, so we are going to need a subscript of 2. Okay, and then our compound is therefore going to be sodium and chlorine. Okay, so let's balance our equation. We have 2 chlorines on this side, but only 1 chlorine here, so my coefficient needs to be a 2. Chlorine is now balanced. Let's go to sodium. Sodium, we only have 1 here, but 2 sodiums here, so we're going to put a 2 there. Sodium is now balanced, so let's take a look at iodine. Iodine, we have 2 on our reactant side. We have 2 on our product side. So our reaction is actually now balanced. Okay, so this concludes our 4 rules for single replacement. Remember that the hardest part of our test is actually single replacement because there's so many different rules to memorize. Okay, rule 1 is metal and a metal. Okay, remember metal can only replace that other metal if it's higher on the activity series. Okay, rule number 2 is a metal reacts with acid. Okay, that metal has to be higher than hydrogen on our activity series. Okay, rule number 3 is a metal reacting with water. So our metal has to be sodium or higher. Remember, there's only 5 metals that will react with water. And then rule number 4 is halogens will only replace other halogens. Okay, so like replaces like. It's important to remember that positive atoms are only going to replace positive atoms. Negative atoms are only going to replace negative atoms. Okay, so think of it as metal replaces metal and non-metal replaces non-metal. Okay, so if this has already confused you, just the last portion of what I've said, then you should definitely try to memorize these 4 different rules, because this is where my students have problems on the test. Okay, so remember to subscribe to my videos. If you guys have any questions, just let me know. Tutorials are always on Wednesday mornings or Wednesdays after school. Okay?